plumbing, wiring, insulation, paint, plastic floor tiles, appliances, what we use in domestic purposes, computers, furnitures, food, especially fertilizers. The fertilizers we use, it has to have a lot of minerals. In drugs also, cosmetics, okay? And there are a number of other things, utensils, jewelry. Jewelry is very important. Number of things. So, of course, we will keep studying metallic and non-metallic. So, if you try to see these, what are the mark metallic? So, they are the products of the metallic minerals. Like steel, if you have to have iron, aluminum, bauxite, copper, you have to have copper ores like chalcopyrite, zinc and titanium, zinc, sphalerite, titanium ilmenite, titanium sands. All these things are very important. Another group is hydrocarbon. Of course, we are not going to deal with hydrocarbons. Originally, hydrocarbon was also a part of the economic resources, but nowadays it is dealt separately. Hydrocarbons are dealt separately. And rest all non-metallic. For example, if you are using sand for construction purposes, gravels, okay, clay, okay, for example, gypsum, all these things are non-metallic because they do not have a metallic component. In our course, we will keep studying a lot of metallic, non-metallic, and that too when it comes to geological technology, next semester, we'll be having a separate course. So there we'll be studying a lot of metallic minerals. So you are seeing some beautiful diagrams. For example, you see a beautiful building, just like our main building, a beautiful structure, Roman architecture. Okay, you find all cars, huge cars, and you find aeroplanes, you see the runways. For all these things, minerals are important. For construction, you have to use limestones. Okay, for cars and other automobiles, you have to use a lot of steel. Okay, for aeroplane, you have to use a lot of natural materials. And for even the runways, for the aeroplanes to land and take off, you have to have the runways with a lot of natural material. Lime, cement, Portland cement, special compacted sand. So a lot of things are there. Okay, so likewise, every equipment, appliance or machine, they're all made up of minerals. So that's why the mineral studies are very important industries. Yeah, I don't know how many of you have you ever seen any mines? Of course, Jain was telling, no? Jain, what Jain? Akshay. Akshay Jain?
Sir, Anshul Jain. Anshul.
Anshul Jain. Have you seen a mine like this?
Sir, clear नहीं है sir picture is समझ नहीं आ रहा.
Your voice is not clear. You see, all of you have to keep your computers, your laptops, your mobiles in a perfect way. See, if you are unable to interact, then it is absolutely useless. See, of course, basically these are all underground mines. Okay. So underground mines, mostly the private companies, they don't operate except Vedanta, Rio Tinto, big companies. Otherwise, no small companies, they go for surface mining. Mostly the surface level mining. If you want to go for underground, a ore body like this, so there is a reason for why we have underground mines. There is a mineral economics is there because the amount of overburden is so thick. If you remove it, keep on removing, then the economy will be very, very in a bad condition of the mine. So what they do is they go for a shaft. They go for a vertical shaft and they approach the ore body through crosscuts, through adits. There are a number of mining terms are there. So mining industry itself is very huge industry. Mining industry is equipped. So of course, these are some of the questions are there. Okay. Basically, it's a very rough job, very tough job. Anshul, you must be knowing, very hazardous. A lot of tough job is involved in mining engineering. That's why I don't know whether any of your friends are doing their BTech in mining engineering. You can talk to them. It's a very, very difficult job. Yeah, this is a cartoon. It shows a small baby. Of course, if you see the posture It is inside. The baby is about to be born. Okay. So they say that a newly born American baby starts consuming 60 kilogram of minerals. So these are statistics that they got right from the birth of a child till its death, okay, dying at the age of 80 years. So for about 80 years, each and every person consumes 60 kilograms daily. So you can calculate America, you can calculate Canada, you can Australia, India, China. So much of natural resources are needed to sustain the industries. So it shows that we have huge industrialization, prosperity, very high living standard, a lifestyle. All these things you have to have high level mineral resources. For example, what you find your Gurgaon or your Hyderabad or your Bangalore, the high-tech cities, huge buildings, huge infrastructure. It's all because of natural resources. Of course, the manpower is involved, but for the manpower to go and work, you have to have the infrastructure. So for the infrastructure, you have to have natural resources. That's very important. But something very interesting is certain countries they use very high. For example, USA is 5% of population of the whole world. They use 33%. That's why they are at the top. So they say that when you start using more and more natural resources, that means your economy is in a very high level. Is it right? So this is how population growth is compelling to produce minerals. Yeah, they are compelled. So when it's compelled, then you have to go for a lot of exploration. If you want to go to exploration, you have to know the concepts. Now, if you have to know concept, you have to understand the geology of mineral deposits. So all these things are very important. Yeah, there is a long list is there. Computers, yeah, computers. They consist of they are made up of certain compounds like aluminum, cobalt, copper, gold, iron, molybdenum. All these things are natural products. Barite, beryllium. Okay, for example, agriculture. You find all your excellent agriculture in Punjab, Haryana, many parts of Kaveri Delta. For that, you have to have a lot of fertilizers. So all the fertilizers has to come from minerals. Very important. Of course, there's a long list I don't want to go through. Right from carpet industries up to telephone industries, so many industries are using natural resources. So I don't want to go into more details. I think you can read. I think some of you must have downloaded some books. Saket, you download any books in economic geology?
Yes, sir.
Saket?
Yes, sir.
Yeah. What book did you download?
So it was like economic geology by
By whom? By who?
Walteri.
Walter Pole.
Yeah,
That is Walter Pole. That's a
Walter
good
Pole.
book.
Yes.
Yeah, Walter Pole. That's a good book. Please read that book. It gives all these details. Okay. A teacher only throws light. That's all. A student he has to learn many things. Okay. This 45 minutes, 50 minutes is not sufficient. No, many of the things has to come from your side. And basically, all of you are quite intelligent students. Okay. So there's a power industry. Without power and energy, industries cannot sustain. The world will become dark. No? So a lot of things are there. I don't want to go in details. In USA, about 57% of the the energy comes from coal. India, 68% comes from coal. So coal is a major mineral resource. One has to understand the coal beds, coal geology, coal exploration, coal mining. Coal India Limited is one of the huge organization employing a lot of mining engineers, geologists, mineral processing engineers. Have anyone of you have seen this type of huge machines? Anyone coming from Rajasthan? Have you seen any mines? Have you seen this type of huge machineries? In fact, they say the largest man-made equipment on the earth is bucket wheel excavator. 13, how much? 13,500 tons its weight. It is used for the excavation purpose. It can produce 10,000 cubic meter of mineral per hour. Very huge. I don't know anyone has seen Neyveli. If your father is working in Neyveli Lignite Corporation or in some of the bauxite mines or Vedanta, you must have seen this type of trucks, you find only the mining sites. So mining and mining machineries are very important. A lot of scope is there for mechanical engineers. Mining machinery is very important. Let us try to see sort of basics of mineral resources. Yeah. So what exactly mineral resource? It is a usable economic commodity extracted from naturally formed mineral. Yeah. So the naturally formed minerals can be element, it can be a compound, it can be a minerals, or it can be rock. It can be any damn thing. It has to come from the earth. You have to excavate and take it out. It becomes a mineral resource. Of course, all these things you will study later as a part of mineral economics. Okay, so reserve, they use certain kind of reserves, resources, okay, inferred resources, portion of a resource that is identified and currently available for extraction. It's called reserve, reserve of ore body, ore reserve estimation. So what are the defining factors? One has to understand the geological concept, the technological aspects of mining, the economics of the area, and legal factors. These are very important nowadays. In fact, many of the mines are not able to start because of the legal factors, because of the environment, because of so many other legal problems. So as I told you, they are not renewable. Okay, we have only finite amount of mineral resource, but there is a growing demand. Every year it's increasing because of technology. There's supply shortage due to globalization, because many of the things are produced, sent to some other places. More developed countries, they consume more. That's why it's called disappropriate. For example, Africa is one country, produces a lot of natural resources, but it doesn't consume. It all goes outside. That's why the country is very poor. So they produce a lot of things, but goes out of Africa, the Mozambique, Tanzania, your whole Zambia, South America. South Africa is slightly better. Other countries like Uganda, Kenya, Nigeria, a lot of countries, they produce a lot of natural resources like diamond, copper, lead, zinc, uranium. They are trouble because it all goes outside. That's why now highly developed countries use most of the resources. So once again, there is a geopolitics. So how to solve all the problems? You have to find more resources. How will you find? Of course, yeah, that will come later. Otherwise, you have to go for substitutes. This is where comes your metallurgy, material science, or recycling. This can come in a very big way. So use less and make more efficient use what is available. This is the recent concept that's coming in a big way. Live without all these things. That is the best. Go to Himalayas. Go to jungle. So you need not use all these natural resources. Of course, that's ultimate concept. Yeah, this is a particular beautiful diagram. It has been shown for natural resources. For example, if you rapidly use all the natural resources, suddenly it will come down. So you with time. So the next generation will not be able to use. Another one is conservation. Yeah, that will go still a long way. Then conservation and recycling, that is a good one. Yeah, the plateau will be there. Yes, it will maintain. So this is a good concept. This is once again a very good one. So nowadays, the conservation recycling is very important. Of course, we will study about metallic ores. They are basically metallic minerals. All these things we have discussed. Of course, this we will study in the course, what is called concentration factor, because there are certain minerals or certain metals, they need different concentration factors. For example, gold is 5,000. For aluminum, it will be less. Iron will be less. For cobalt, it will be slightly different. So each and every metals, they have different concentration factors that a geologist is supposed to understand. Yeah, this is more of geology. So of course, already I discussed in the last class. Okay, you have different types of deposits like igneous deposits, metamorphic deposits, sediment. Already I discussed the last class. Sometimes they can produce biological activity also, weathering process, surface process. You can have diamond deposits, bromide, magnetite, beryl, which is very important. Lithium, yeah, coming in a very big way nowadays. Lithium, rare earth elements, copper, lead, zinc, asbestos. Of course, nowadays restricted use is there for asbestos because environment is more dangerous. You need minerals like potassium. You need gold for ornaments, uranium, strategic. Okay, sand, gravel is very important for construction purposes. Manganese, all very important for steel industries. Phosphorus, very important for fertilizers. Bauxite, aluminum, copper, all these things are important. They occur in different countries like South Africa, in Australia, Canada, America. Different countries are there. In India, we produce a lot of minerals. How things are going on? Okay,
सही है सर.
नहीं चल रहा. So all these things will be available in water pole. Did you study any concept called plate tectonics?
Yes, sir.
Can you tell?
Yes, sir. The
What plate
plates.
tectonics? What plate tectonic has to do with mineral resources? Tell me. Someone was trying to talk. May you know who is talking?
Rhythm.
Rhythm. Oh, good, very good, very good. I am happy, Rhythm. Yes, interact like this. You will get better grades. More and more interaction, your grades will be good. Yeah, tell me, please.
Sir, the
I'll be happy.
lithosphere is divided into many plates.
Very good, excellent. I am happy that you used a term called lithosphere. Beautiful, very nice, Rhythm. Excellent.
And the layer beneath is the asthenosphere, which is
Very good. Both
partially
body.
molten
Melted, partially melted, yeah.
due to the convection currents which are set up in the mantle.
अरे बहुत बढ़िया, fantastic यार, very good, excellent. बताओ और बताओ.
The plates, the lithospheric plates, they move. They either
Beautiful.
go away from each other or move towards each other. That are
Very good.
divergent or
Yeah.
convergent boundaries,
अरे बढ़िया,
and
बहुत
there
अच्छा.
may be transform boundaries also
अरे
with a
classical,
slight path.
classical, very classic. Excellent, excellent. कितना grade मिला आपको subject में?
10.
Very good. Okay, I am very happy today. मजा आ गया. अच्छा,
Thank you,
कहाँ
sir.
से आप? रिदम?
Sir, Panipat.
अरे wow, beautiful, beautiful, excellent, very nice. Keep doing well. Okay, so these plate bend boundaries are related to many of the origin of deposits. Many of the volcanogenic massive sulfide deposits we have been seeing last class, they're all produced in the divergent margins. There are a lot of deposits which are in the where it is consumed, where the plate is consumed. It's called as destructive margins, or where the subduction is happening, where you will have very high temperature, high pressure. Okay, so a lot of metals can form. Example is gold, porphyry copper deposits. So there are a number of deposits like iron, gold, copper, mercury. They all form along certain boundaries. So plate tectonics is very important to understand. बहुत बढ़िया, एकदम मजा आ गया. Yeah, so you can see, I told you, the divergent margins, where the plates are diverging. So you will have a heat source, and you will have the oceanic ridges where the black smokers, it interacts with oceanic water. We will study all these things, the circulation of seawater, because they are salty and they will bring the metals, and they precipitate the ores, which are called as the massive volcanogenic ore deposits along the oceanic ridges. Yeah, but it's not that easy. Mid-oceanic ridges. Can we mine? People are asking question, can we mine? No, it's not that easy because your marine environment, one has to be very careful. Marine life, marine environment, very important. What happens? Subduction zones. Yeah, I told you, subduction zones, lot of things happens. Like when the plate is going down, the plate will be consumed. Will go for partial melting. What Rhythm said. Then melting can take place, and that can produce a lot of protons. And sometimes the metamorphism can take place that can produce metamorphic waters. The metamorphic waters can leach a lot of metals, and it can come quite close to the surface and it can deposit. Yeah, yes. So these are some of the tectonic features. These are the areas where have the tectonic activities. Is it right? So these are the ridges. These are the ridges. These are the ridges. Okay. So these is subduction zone. So all these things are subduction zones, and you find certain important things. We see certain deposits. Certain deposits. There are deposits here. Major deposits. Okay. So this type of plate tectonics can be applied to understand. And whenever you go to new area, you can try to understand the concepts, whether there was a divergent margin, subduction margin, transform fault, transgrund fault. So all these things can give a lot of knowledge, and the knowledge can be used to construct the geological models, and the geological models can be used to produce, to discover new deposits. Yeah, of course, this is a small sketch. I told you last time the contact metamorphism. No, like you have certain shale limestones. No, you can have a granitic rock intruding, and it can alter contact areoles. I think probably metamorphic petrology probably you are studying geological technology, and probably in basic petrology you must have studied produce an areole called as contact areole, and sometime you'll have the deposits. They are called as contact metasomatic deposits. I will not go much into the details of environments. Environment itself is a very big topic, but these mineral exploration and mining, they create a lot of hazardous activities which can destroy the environment. Nowadays, environment engineers are there, environmental experts are there. They just try to see how it can be managed. Environmental management is very important. I don't want to go into more of these environmental aspects. The separate subject, environmental geology, you will study later. Yeah, so surface mapping is very important. Geochemical studies are important. Geophysical studies are important. This is where comes the geophysics people. Remote sensing is nowadays a very important tool, and a lot of test drilling important. Then only, because what are the surface studies we are doing on the surface? It's all models. But at the end of the day, you have to find a drill. You have to find out deposit, whether it is 600 meters below, it is 1 kilometer below, 2 kilometers below. You have to drill only. So test drilling is very important. Okay. So I don't want to go into the environmental aspects. I don't know it's environmental. I don't want to go much. No much. I'll just show you some pictures. You see, it's such a beautiful hill, no, beautiful terrain. But when the mining is happening, so they are mining this particular part, and you see the acid, the drainage. It produces a lot of environmental effect. It's called tailings. Tailings. So they should treat it. Environmental engineers play a very important role. At the same time, you need metals, for industrial development. You have to have the metals. Without that, you cannot progress. But at the same time, that can be more dangerous. Trace element leaching into the water, like cadmium, cobalt, copper, lead, all toxic. This can affect. So we have to manage. Acid mine drainage from tailing, we have to manage. This is a very big field. I don't want to go into more into all these things, not necessary. There are wetlands, wetland developments, wetland management. I don't want to go into. These are all tailings. A lot of leached materials are there. See the color of the water. It has to be managed. Yeah, recycling is a good concept because we cannot produce things which are toxic, dangerous. Soil, water is affected. So best is recycling. Recycling is the best concept nowadays. I will not go into more details. Please read. Please read books. Please read books. Yeah. Biotechnology is coming up in a big way in mineral industries. People are using a lot of biological components to leach the metals. Certain, for example, if you just put a heap there and develop certain bacteria and certain things, so they will start leaching. They will eating, and they take out all those biological components, and they finally will be able to process. So a lot of things are coming up. Biotechnology is coming up in a big way to stop the environment. They can selectively, they can consume certain metals. Yeah, I'll just, before concluding this talk, let us just see what is happening in India. We should know what is happening. We have been talking about America, Canada, Australia, South America, uh, Zimbabwe. Let us try to see what is happening in India. Okay, out of 1,100 minerals, India put 90. We are self-sufficient 35. Our population is 16% of the globe. So we have to consume more. They say we have to consume more. Okay, what is exactly happening? Of course, we will come. So we have asbestos deposits, very good barite deposits. We have huge bauxites. We do have China clay for porcelain industries. We do have chromite deposits. Not much, but okay. Not bad. This is a global share. 10.8% of the global is from India. Bauxite around 10%. Chromite 10%. Coal 25%. 1/4 of the world coal resource are in India. Okay, copper, of course, we are very less. Diamond, once again, we are, though we have some deposits, we are very less. Iron ores, we are quite huge. Around 6% of the globe, the iron ores are produced from India. Manganese, not bad. Magnesite, we are quite good. So like that, we do have minerals. Okay, but nowadays this industry is coming in a big granite industries. What Anshul was telling, no, probably they are mining granites for ornamental stones. It's very easy to mine and easy to make a lot of money. Once you polish it, it takes a good, good look, very beautiful look. So people buy it. For example, most of the granites exported to Japan, to China, to Italy, to different countries. See, marble was widely used those days. But marble has got some problems because the hardness is around 3 or 4, so it can leach. It can have a lot of pits. Whereas granite is very strong, very hard. So that is used in a big way nowadays as ornamental stone. So what is happening in India? We have been mining in India for the last 150 years. Our after independence 75 years. Before that, Britishers were there. They were mining. So 150 years of mining, it's so we are having only limited quantity now. Many of the things are gone. And now we are left only the low grade and they are scattered. Very good things we have taken out. Either they are thin deposits or very abnormally thick deposits. And many of them are now only deep seated. The surface deposits are all gone. Now we have only the bottom deposits. Okay. And many of the deposits are geologically disturbed. Like some of the places where either tectonic acted, we did not go for mining because no, they are packets. You will not have them in one particular place. And remotely located, yes. Whatever is quite closer to big cities and towns, we have been able to extract. So our concentration is more on the deeper seated deposits and remotely located deposits. So because of all this, currently we are having a poor recoveries. We are spending more money, we are not able to extract much, and this will lead to shortage crisis. So this particular aspect was well studied, well thought about by the Ministry of Mines, and we are doing something, no doubt, but it will go a long way because we are not so good like Australia, Canada, or even US. The reason is that we have a lot of politics, a lot of political problems. One small example, we have some of the best diamond mines or by diamond deposits in Chhattisgarh. They say that it is as good as the South African diamonds, but we have not been able to mine because of the political problems. Of course, these are some of the modern mining. You need not take out the coal outside. You can go for gasification here itself. So you can take out the coal gas. It comes straight and can produce electricity. Your borehole mining, the ore need not come to the top. It can be extracted there itself. And you have leaching. I told you the biotechnology. You can go for a heap, and you can have a lot of sprinklers, chemical and lot of sprinklers. So these will have water and plus acid. So it will leach, and you see this coming out. These are all metal bearing. No, you don't spend much money. and processing. So more and more better technologies are coming. Okay, so you can go for low grade and thin deposits, scattered deposits. You can use the old dumps. They are less cost. They can give better recovery. So a lot of technology like borehole mining, coal gasification, bioleaching, chemical leaching. It's called heap leaching. Yeah, yes. In situ leaching. All these things are coming so that the minerals can be extracted in a better way. So another thing is that mining machineries. Yeah, yes. A lot of research is going on to produce better mining machineries. So that is part of the mining engineering. I don't want to go into more details. It's not our job. But one thing is there R&D is important, research and development. Mineral processing is very important. So all these things are important. So integrated. So let us stop here. Stop sharing. Yes. So there are 34 students today. Let me call by name. Akshat.
Sir, present, sir.